Hello teacher. My name is Nguyễn Thanh from class 22GT1. I'm a member of Group 3 and today I will present Lab 2. Let me introduce you what is CPU SIM, what is register and memory, and then I will practice the exercise in Lab 2. So let's move to the first question. What is CPU SIM? CPU SIM here stands for CPU simulator, meaning that this software simulates how the CPU works. As you know, inside CPU we have register bar, which are memory directly attached to CPU, providing storage external to CPU. And because they are directly attached to CPU, the CPU operates very quickly with the variable on register. However, the number of registers on CPU are very limited, while programming a lot of space to execute. Therefore, here the CPU will also have main memory or RAM to store the data needed to execute the program. We can configure the configuration of the component in CPU SIM. Now, what is the register and memories? In memory section, we have ACC, IR, MAR, MDR, PC, and one more that is status. ACC here is accumulator. Is a record of ACC is used to store the result of calculation or comparison. When the calculation or comparison is secured, the result is stored in the ACC. The result can be used in the further calculation or comparison. AR stands for instruction register. It's used to store the opcodes of current command being executed. The opcode tells the CPU what action to take. MAR stands for memory data register. MAR is used to store the address of data that needs to be read or written from memory. And MDR stands for memory address register. It's used to store the data read from memory or data written to memories. The last one is PC, stands for program counter. PC is used to check the location of running program when an instruction is executed. The PC is updated to indicate the address of next instruction that needs to be executed. That is in Next is memory section. Memory section we have to about that is address column and data column. Address column here is used to store the address, and the data column used to store data. So now I will practice the exercise. I will open my program and machine I will create and the machine. Here you can see the setting of the machine and program, the register bar, RAM, let's see the increment here is due to let's BC port to the next address due to will be executed. That instruction will be queued. You can see here we set the length of data and instruction is 32 bit, meaning one word equals 4 bytes. In instruction word consists of 8 bit opcode and 20 bit address. Therefore, the BC and MAR register is 24 bit long. The status here is store the state of CPU, and in memory section here we can see here that a bit we will have one address, meaning 1 byte is one address, and the mention before one word equal 4 bytes, so we know that for address are needed to store one word. In lecture here there are few code snippets through the program to calculate the sum of positive integer until it encounter a negative integer like the last one. After we load the program, the instruction will be stored in memory, with its instruction being for address here. Example 0 is reach, and for here is jump. Now I will run step by here to see what happened. The first is MAR will store the address that PC holds here, and then MDR will get the data from the address MAR holds here, then push and then transfer the data to IR to decode. Next is PC will point to the next address. I will enter this integer. The one here HCC is used to store the value I was entered. Then we done the reach instruction. Now PC will point to the MAR will store the address that PC in PC here, and then MDR from the address of MAR, MDR we will get the data from this address and transfer it into AR to decode here. Because I enter the values is 1, so we skip this instruction. Then it's also loop. Let's see. 1000 here. Then PC will point to the next instruction here in the address of instruction star. MAR will store this address 1000, and MDR from that MDR will get data from that address and transfer it into MAR to decode. It starts, and then MAR will get the address from the last instruction and to get the variable sum and add with the ACC to get the new sum and start it in ACC. The result is also 1. And then we will start the values in ACC to the memories. Then I will enter a negative number to end the program, and I will step by micro to see it clearly. Okay. So last. I will step by micro to see it more clearly. First is MAR will get the address from BC, and then from that address MAR the memory from the address that MAR holds. We will get the data from register or from memory and store it into NDR here. The data, and then transfer it into IR to decode here. And then increase BC to the next instruction that is done. This allows us to enter an integer. And the value I enter will start in ACC. See here, and like that. Then this MAR will get the data from PC, and from MAR we will get the data through MDR and then transfer it to IR to decode. And then we increase PC for light to the next instruction. That's it here. Because the value I enters is positive number, so we skip it and move to the end. And now the PC here point to the next instruction here, that is address of the instruction of this instruction. And then it's nothing to say, it's just like normal here. I will run it through the code to see it. It's here, the instruction add here will allow the MAR get the address of get the address of lots of variable here, a variable sum in memories, and from that we will get the data from memory input into MDR. And then the ACC will plus with the value of ACC will plus with value in MDR to get new value, to get new sum, and store it into ACC. The result is also 1 because 1 plus 0 is 1. Then is star. Next instruction is star. Yeah, decode. And the star, it will store the value from MDR to the memory. For that, the MDR will get the data from ACC and then store it into memory where in the address of MAR hole. Here, MDR will store the value to main memories. Okay, we will back to the instruction and PC will, as here PC will point to the first address in 0000. That's a read instruction. Here you can see when that will be the instruction, the address will be moved to here. What was now I will enter the negative number. Because I enter the negative number, so because I enter the value is negative number, so we will move to the next instruction. Here the PC will point to the address of variable sum here to load the variable in memories and write it into and bring out the output into the screen. Here. Got here. MAR will get the address of variable sum, and then the MDR get the data from that address. And install the value of MDR to AC. we will move to the next instruction in right. Here, right is used to bring out the final result. Final result in of variable sum here into the screen. You can see here. Then see the end of the program. Thank you for listening.